Good evening, Titans. This is Mr. Simpson, and this is the last video for Chapter 1. And tonight it says the essential question is, how can you use a formula for one measurement to write the formula for a different measurement? The things that we will learn is how to rewrite literal equations, how to rewrite and use formulas for area, and rewrite and use other common formulas. Tonight we're going to start off with a little vocabulary. First of all, a literal equation is an equation that contains two or more variables. So far we've been solving equations that have just the same variable throughout. Now we'll have equations that have two different or more variables. And a formula is just a type of literal equation that shows how one variable is related to one or more other variables. And those are some of the common formulas that we'll use later. So our first example of a literal equation is we're going to solve this equation, 3y plus 4x equals 9. We're going to rewrite it so it's y equals. We want the equation to be y equals. So anything that does not contain a y is considered now just a constant term. So we have to get rid of the 4x. So if I change sides, change signs, and I move that over there, I have 3y equals, and now the 4x becomes a negative 4x plus 9. Now again, we can't combine the 4x and the 9 because those are not like terms. Now we need to isolate the variable y. So we do that by dividing every term by 3. Now, you'll see that sometimes they just divide each side by 3, but usually if one of the terms can be divided by the constant that we're dividing by, in this case the 3, then we'll rewrite it and we'll divide every term by that. So now our answer would be y equals negative 4/3 times x, and then 9 divided by 3 is plus 3. And now that's our final answer for rewriting that literal equation in terms of y. Here's another example. This time we want to solve for x. And in this case we have two different terms that both have the variable x. Unfortunately, these two terms are not like terms because the second term contains the variable z. So we can't combine the 3x and the 5xz. But we can't also have two values of x. Since x occurs in both terms, we can undistribute the x. So we're going to put the x on the outside of the parentheses. And if we take it away, if we undistribute it from each of those terms, we'd have 3 plus 5z. And again, if you look at this, if we were to distribute the x back through, we would get exactly what we had to begin with. So we call this undistributing. And now we have y equals x times 3 plus 5z. And since we now want to solve for x, the factor that's being multiplied by x is what we're going to divide both sides by. So we'll divide both sides by that sum of 3 plus 5z. So then our final answer just is x equals y on top all over 3 plus 5z. And there's our final answer. Now I'd like you to pause the video and try these. I would at least try I suggest you do number 1 and you do number 4. Alright, here I am to reveal the answers. So for number 1, your answer should have been y equals x divided by 3 plus 3. Now if you did number 2, your answer would have ended up y equals x plus a negative 5 halves. And you could have also written that as x minus 5 halves as well. Either way. Number 3 is a little bit easier because 5x and 4x in this case are actually like terms. So we get y is equal to, well, 5 minus 4 is 1x, so we get y is equal to x, which just means x equals y. And the last one, again, we'd have to undistribute that x to give us x times 2 plus k is equal to m. And then to solve it, we'd have x is equal to m divided by 2 plus k. Alright, now we're going to look at a formula. And so here's just a formula of our surface area of a rectangular prism. And so we need to solve this for L this time. Well, if we notice, there are two terms that have L, and this term here does not. So we first have to move that term to the other side. And this is where that change sides, change signs can become handy, because we want to get rid of that. So if we move it to the other side of the equal sign, it would become a negative. So I'm going to write it as S minus 2WH equals 2LW plus 2LH. Now again, here's where we have two terms that both have L in them. So we first have to undistribute that L from those two terms. We end up with 2W plus 2H equals the S minus 2WH. And now our final step is to divide both sides by what L is being multiplied by. And our final answer will look like this. So L is equal to S minus 2WH all over 2W plus 2H. Now another example. Now this one, we have to kind of draw a little picture here. Here's our lot, and it says it's 500 feet deep, and this is our frontage right here. Okay, that's our frontage. So if you're driving by, here's the road that you'd be driving by, and so this is the front of the lot, and it's 500 feet deep. And there's the area of this is 100,000 square feet. And so what we need to first do is they want us to find that width. So we know the area of a rectangle, area equals length times width. And if I want to find width, I'm going to take W is equal to the area divided by the length. So in this case, the area, which is 100,000, divided by 500, my width would equal 200 feet. So this length right here is 200 feet. So I've answered part A. Now it says, how much are you assessed for the new water system? Well, this says it's $5.50 per foot. So it's $5.50 per 1 foot. And we're going to multiply this by 200 feet. So the feet divide out, and now it's $5.50 times 200, which would be $1,100 that we would be assessed. Now I'd like you to try these, but before we do, this first one, number 7, should be A equals 1/2 base times height. And this one, the surface area of this cone, should be written as S equals pi times the radius squared plus pi times the radius times the L. So go ahead and pause this for a moment and then rewrite these, solving for the given variables. Alright, so for number 7, it should be H is equal to 2 times A over B. And for the surface area 1, it should be S minus pi times the radius squared divided by pi times the radius. Now, here's a core concept of some common formulas that we're going to end up using. So these are in your journal. So again, you just may want to highlight these, and these are what we're going to use. So first it says just solve the temperature formula for F. So we want to solve this for F. So the first thing we have to do is get rid of the fraction on the outside. So we don't have to distribute. All we have to do is multiply both sides by the reciprocal. So I'm going to multiply both sides by 9/5. And if I do that, this 5 divides with this 5, this 9 divides with this, and we get 9/5 times C now is equal to F minus 32. And now to solve for F, we would add 32. And again, those aren't like terms. So now we have the Fahrenheit temperature would equal 9/5 times the Celsius temperature plus we would have to add 32 degrees. Again, here's just another one. And we would substitute these values in, and we're not going to worry about that. And then here's another one, just simple interest. You deposit $5,000 in an account that earns simple interest. After 6 months, the account earns $160.50 in interest, was the annual interest rate. And so they give you what everything is. Remember, time is measured in years, so 6 months would equal 0.5 years. So you deposited your principal, so the interest you earned was $162.50. The principal that you put in was $5,000, and that was after 6 months, so that's 0.5, and then you want to find the rate. So we do this, we have 162.50 equals 2,500 R, and now we divide both sides by 2,500 to find our interest. And so our interest rate, so when we divide this, we get R is equal to 0.065, and if we write that as a percent, the interest rate would be 6.5%. All right. Okay, sorry that one took a little bit longer. That's at 12.5 minutes, and we still probably have a couple things we'll discuss with this, but have a great rest of your evening, and remember we have a test on Friday, so we'll cover this stuff Tuesday and Wednesday, and a test on Friday.